Here we are, children, we are going to discuss about law of conservation of energy. So it is said energy can neither be created nor destroyed, but only can be converted from one form to another form. So once again try to understand that energy can neither be created nor destroyed, but it can only be converted from one form to another form. So that conversion is called transformation of energy. Like a tube light will convert electrical energy to light energy. A solar battery actually converts solar energy to chemical energy. A battery or a cell is a device which converts chemical energy to electrical energy, and so on. So a lot of, like a scooter, when you have started and it is running, so actually combustion of fuel is taking place. So heat energy is being converted to mechanical energy in moving vehicles. So these are different transformation of energy. Now I am going to prove that the mechanical energy of a free falling body from a particular height remain conserved at all the time. So let us try to see. Let us try to see a body is at a height h above the ground, h meter above the ground, h meters above the ground. A body is at a height h meters above the ground, its mass is m kg, and its position is A, and it is just being held by me. Say for example, I have held a body of mass m kg at a height h meter above from ground, and I am going to drop it. So that I am just going to drop it. So what will be its total energy? So try to see, children. Total energy, I can write it like this. Total energy at A will be equal to potential energy at A plus kinetic energy at A. So potential energy is mgh, the height is above the ground is h, plus kinetic energy is half mv square, but its velocity is 0, isn't it? I am just going to drop, so its velocity is 0. So that means it will be mgh plus half m0, that is 0. So total energy at A is mgh. Now suppose the body has fallen down to position C. So what is the, just about to hit the ground, the body is just about to hit the ground, it has fallen down the whole height. So total energy at C will be what? Total energy at C will be potential energy at C plus kinetic energy at the point C. So mg, but h means height above the ground, which is 0. Kinetic energy will be half mv square. Now we know that v square is equal to u square plus 2as. Velocity square is equal to u square plus 2as, that is this is third equation of motion. So I take down this, the body is falling down, so v square, it has got a final velocity that is equal to u square, which was 0, plus 2. A will be acceleration due to gravity, and s means how much distance the body has covered during its fall. So it was at h and it has come down the whole way, so it is 2gh. So here total energy will be equal to mg0, that is 0, plus half mv, v square is 2gh, so 2 cancel. So total energy at C will be mgh. Now suppose this body has come to this position. So the place is B. So this place is B. Suppose during its fall, I take a midway where the body is at this instant, it is at B. So what will be the total energy here when the body is actually traveled x meter down? Total height it had fallen was h. But suppose I have taken here and here. Now suppose in between I have to take. So total energy at C, at B. Total energy at B, what it will be? Total kinetic energy at kinetic energy at B plus potential energy at B. So kinetic energy will be half mv square and potential energy will be mgh. Now half mv square. Now what is v square? V square is 2 into g into the distance which it has fallen. S actually it comes from this formula, no? V square is equal to v square plus 2as. 2 u is 0 for this, a is g, and s means distance covered during its fall. So this is the distance it has covered, so it will be x. So that means half m2gx. This 2 is cancelled, so it is mgx. Now let us take mgh. Mg is okay. H means, in case of potential energy formula, H means the height above the ground. So what is the height above the ground for this body? Total height was h, it has fallen down x, so it has still to cover h minus x distance, so that is the height above the ground. H is the whole thing and x has fallen down, so the left distance is h minus x. So I put over here mgh minus x, so it will be mgh minus mgx. So this cancelled, so total energy at B now is mgh. So see, all the cases, total energy at A is mgh, total energy at C is mgh, and total energy at B is mgh. So all the places the total energy remains conserved. So that is why during the numerical problem you can easily solve the numerical problem. Suppose they say, first you have to also understand, when the body falls from a height, its potential energy is the maximum because the value of h is maximum, and its kinetic energy is 0 because it does not have velocity. But as soon as it's falling down, the height is decreasing, that means potential energy is decreasing, but the velocity is increasing, so kinetic energy is increasing. So when it just touches the ground, since there is no height, what happens? The potential energy becomes 0 and all that potential energy will get converted into kinetic energy. That means if somebody tells you the potential energy here is 4000 joules, so what will be the potential energy here? So it will be 0, but its kinetic energy will be 4000 joules because the total energy will be transformed, the P will be transformed to K, and right in the middle it will be half. Like if they say right in the middle of this fall, what in the middle, exact middle, what will be the potential and kinetic energy? So you know that total energy over here is 4000 joule. When it falls half the way, half the height, obviously you will divide by 2. So the potential energy will be 2000. 4000 divided by 2 is 2000. And then here P and K should be equal. P and K should sum up to 4000 because total energy 4000 here. So total energy 4000 here. Out of that the potential energy is 2000. So the kinetic energy will be also 2000. So gradually through the numericals we will try to understand this concept more. Thank you.